Hello friends, welcome to Learner's Planet. Friends, this is our first session for Basics of Geometry. In this session, we are going to discuss some basic terminologies and concepts of geometry. Understanding these basic concepts will definitely help your understanding of other areas of geometry. So let's begin the session. Now, let's discuss the first term, that is point. Now, what point is? In geometry, we use points to specify exact locations, or we can say point shows position. It is actually the basic unit of geometry. Okay, we generally denote point by a number or letter. Let's see over here. It's point C, point B, point A. Okay, because points specify a single exact location, they are zero dimensional. Means we can say there is no length, no height, no width of a point. Okay, or in other words, we can call it as zero dimensional or non-dimensional. Okay. It's a, suppose I put a dot over here. This dot is a point. Okay. Now let's discuss lines. Line in geometry may be thought of as a straight line that can be drawn on a paper with a pencil and a ruler. Okay. Or we can say line is a collection of points that is going endlessly in both directions along a straight path. Okay. That means it is extending infinitely in both directions. Okay. A line is one dimensional. It is having length but no width or height. Okay. Suppose we have 2 points, maybe P and Q. There is a unique line which will join these 2 points. Okay. And we see over here that's a line, and there are 2 points A and B, and the line is passing through these 2 points. Okay, we represent line as AB, and the arrow will be like this. Okay, or we can say a line goes through 2 points and lines continue forever. Okay, so I hope you are clear about the line. Now let's discuss line segments. Friends, a line segment is nothing but it is a part of a line, and it has 2 endpoints. Okay, see, we see a line over here. It is ending over here and over here. A line segment is a straight line segment which is part of the straight line between 2 points. Okay, now to identify a line segment, one can write AB, or we can say we can represent the line this way. The points on each side of a line segment are referred to as the endpoints. See, this is the endpoint and this is the endpoint. We have discussed lines, and we have also discussed that lines have no endpoints. Okay. A line that begins at a set points and ends at another set points. We can say this edge of the table is as a straight line. It's actually a line segment because it is ending. It is not extending infinitely. Okay. So that is a basic difference between a line and a line segment. That lines, the length of line segment is fixed, but the length of line is not fixed. Okay. Now let's see what are rays. A ray is a straight line that begins at a certain point and extends infinitely in one direction. Or we can say it's a part of a line and it has one endpoint and goes on endlessly in one direction. Okay, it has just one endpoint. Okay, now we see over here a ray. It's beginning from point A and it is passing through point B and it is going endlessly in the direction of B. Okay. So a ray is a line that begins at a vertex and it never ends. Okay. So it's a single arrow. In case of line, the presentation is like this. In case of line segment, this is the presentation, and in case of rays, this is the presentation. So it's a line, it's a line segment, and it's a ray. Okay. So I hope you are clear. Now we see of what are endpoints. Endpoints mark the beginning or end of a line segment or a ray. Suppose we have a line segment over here. So these points, suppose these are A and B, these are the endpoints of the line. Okay, a line segment has two endpoints. Okay, but a ray has only one endpoint. It is this. Suppose it is it's P. As it is going endlessly in the other direction, so it has just one endpoint. And a line that is this, it has no endpoint since it is going endlessly in both the directions. Okay. Now let's understand what are midpoints. The midpoints of a line segment marks the point at which the segment is divided into two equal segments. Okay, now we have to be very clear that neither the lines nor the rays can have midpoints because they are extending infinitely in at least one direction. The line is extending infinitely in both the directions, and the rays are extending infinitely in one direction. But the line segment, since it is fixed, so we can find out the midpoint. Here, there are 2 points. The line is passing through. I'm sorry, the line segment is endpoints having A and B, and M is the midpoint of this line segment. Okay, here we see a ruler. It is, suppose I measure a line from 1 to 9, then we see what will be the midpoint. It's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so since there are 8 uh, parts coming in between, so it's 1, 2, 3, 4. We can say this will be the midpoint. Okay. Since the length of from 1 to 5 and 5 to 9 is equal. Okay, so this is the midpoint. That means 0.5 is the midpoint of from 1 to 9. Okay, now let's see what is an intersection. When we have lines, all line segments or rays that meet or cross at a certain point, we call it an intersection point. Here we see two line segments, that is AB and CD, and they are intersecting at a point E. Here the point E is known as the point of intersection. Okay, and the lines are going to intersect somewhere. Okay, unless until some specific condition is there. Okay. Friends, just now we have discussed about intersecting lines, and I told you that two lines are intersecting somewhere unless until some specific condition is there. Now what is that specific condition when the lines are not intersecting with each other? It's when the lines are parallel. Okay, now what are parallel lines? Two lines that will never intersect are called parallel lines, or in other words we can say parallel lines are not going to intersect anywhere. Okay, we see an example over here. This is line AB and this is line CD. These two lines are parallel to each other. That means they are not going to intersect anywhere in the plane. Okay, it doesn't matter how much they are extending. Okay, but they are not going to intersect anywhere. Okay, you see this is a railway track. These two lines are parallel lines. Okay, if extended infinitely, the lines above will never meet. The flag here, this line and this line, this line and this line. 1, 2, 3, 4. 4 lines are parallel. Okay, so they are not going to meet anywhere. Now we see what are transversal lines. A transversal is a type of line that intersects at least two other lines. The lines that a transversal crosses may or may not be parallel. Here we see this and this two lines, and this red line is actually transversal, which is intersecting both of these lines. Okay, these two lines are parallel, but in this case these two lines are not parallel, but still this red line is a transversal. Now let's discuss what is a plane. Friends, Your computer desktop is a flat surface. Your wall is a flat surface. Your ceiling is a flat surface. Your book page or cover is a flat surface, isn't it? All these are part of a plane. Now, a plane can be thought of as a two-dimensional flat surface having length and width but no height. Okay, now it is extending indefinitely on all the sides, and it is composed of an infinite number of points and lines. Here we see it's a plane and there are four fixed points, that is A, B, C, D. These are the part of a plane, but this plane is extending infinitely, okay, on all the sides. We can think of a sheet of paper, and we have discussed the examples of blackboard, your classroom blackboard, your ceiling of your house. Okay, so all of these are examples of plane. Now let's discuss space. Space is the set of all possible points on an infinite number of planes, and it covers all the three dimensions, that is length, width and height. Okay, friends, we live in space. That means around us we have length, width and height all as well. Okay, now let's see what are collinear and non-collinear points. If three or more points lie on the same line, then they are called as collinear points. Okay, if we see over here, P, Q, R, all of them are on the same line. So these are called as collinear points. And A, B, C, they are not collinear since they are not lying on the same line. The line which match A and B is not the same line which is matching A and C. Okay, and now if three or more lines in a plane pass through the same point, then the lines are called concurrent lines, and the point of meeting is called the point of concurrence. We see over here, these three lines are passing through the same point, that is O. So these three lines are known as concurrent lines, and this O, point O, is known as the point of concurrence. Okay. Now let's discuss a very important term in geometry, that is angle. Okay, an angle can be defined as two rays or two line segments having a common endpoint. Okay, we see this is a ray and this is a ray, and this is a common point from which both the rays are passing. Okay, so this is known as angle. Okay, this particular point from which these two rays are passing is known as their vertex, that is the beginning point, or we can say end point. So an angle occurs when two rays meet or unite at the same point. So these two rays are meeting over here, so it's an angle. Okay, suppose I have a B and C. So this is ray BA, this is ray BC, and the two rays are meeting at the point B. So we can call it as an angle ABC or CBA, or we can just call it as angle B. Okay, so it's ABC, CBA or angle B. That is the common end point. Okay, that means generally we write the vertex in between. Friends, we should remember that the plural of vertex is vertices. Now let's take some practical examples where we can find the angles. Now here we see a piece of cake. This is an angle. Okay. This is a piece of pie. We see that's an angle over here. In this scissors we see an angle. In this letter A we see angles over here. This is an angle, this is an angle, this is an angle. So we see angle everywhere around us. Okay. Here we see this array and this is also array. They are meeting at this point, and this is the angle formed. We can call it as angle 3. Or suppose these are the line rays, that is ray AB and ray CB. They are meeting at the point B. We call, and the angle B is formed over here. So we can call this as angle ABC or CBA or just angle B. Okay. Now let's discuss the different types of angles. Here we see the angle X. If this angle is between 0 to 90 degree, then it is known as acute angle. That means the measurement of this angle is between 0 degree to 90 degree. We measure angles in degree, and if the value of that particular degree is between 0 to 90, then it is an acute angle. We see a piece of pie over here. It's a complete piece of cake, and the angle, this particular angle, is an acute angle. Here in the letter A, this particular angle is an acute angle. This is an acute angle. This is an acute angle. Okay. If the value of the angle is 90 degree, then we call it as a right angle. Here we see these two rays are intersecting at this point, and this the angle which they are forming with each other is 90 degrees. So we call them as right angle. Okay. Here it's 9 o'clock. It is showing in the clock, and the angle between the two hands, that is R and the minute hand, is 90 degree. Here we see this and this. The angle between these two lines of an eraser is 90 degree. Okay. So they are at right angle. Now, if the angle between two lines is more than 90 but less than 180, then we call it as obtuse angle. Okay, here this is a ray and this is a ray, and the angle Z is formed between these two rays, and the value of Z is more than 90 but less than 180. So we can call it as obtuse angle. Here we see a clock. It's around 10:30, and the angle between the two hands is an obtuse angle, since it is more than 90 but less than 180. Okay. And this is the straight angle, that is 180 degree. That means an angle formed on a straight line is 180 degree. This is a ruler. Any angle on this ruler is 180 degree. Okay. Now, angles more than 180 but less than 360 are known as reflex angle. Here we see this particular angle. This is the part of angle which is an acute angle, and this is the remaining part. Acute angle is between 0 to 90, and this the remaining part is between 180 to 360. So this is the reflex angle. Okay. Here we see a pentagon. This is an acute angle, but the remaining part, that is this particular part, I just draw it from other color. This angle is an acute angle, and this remaining part of the angle from this point to this point, it is a reflex angle. This is the center, and this complete angle is 360 degree, from which this is between 0 to 90, and this is from between 180 to 360. Okay. So this is a reflex angle, and this is an acute angle. Here in this pentagon, there are 5 angles. We can see 1, 2, 3, 4, and 5. Some of them are acute, some of them are obtuse. So we will be discussing in the activity time. Friends, these are the basic equipments which we use to construct geometrical shapes or figures. Okay, so this is known as ruler, this is a protractor, and this is a compass. Okay, so we will be using all these three in our geometrical constructions. Now let's do an activity. In this activity, we have to show acute, obtuse, and right angles in the following pictures. Friends, this is a hexagon. Here we see 6 angles. 1, 2, 3, 4, 5, 6. Now we have to find out acute, obtuse, and right angles. So we can see this angle is more than 90 degree, and how we can identify that? I just draw a simple straight line over here. This angle is 90 degree and it is more than that. We can see the remaining portion over here. So it's an obtuse angle. Okay. So all the 6 angles in hexagon are obtuse angles. Okay. This is a right angle triangle. This angle is 90 degree. So it's an right angle. This is less than 90 degree. So it's an acute angle and it is also an acute angle. Here we see it's an obtuse angle. Since it is more than 90 degree, you can draw a straight line over here and it will be more than that. I can say it's more than 90 degrees. So it's an obtuse angle. It is also an obtuse angle. It is an acute angle and it is also an acute angle. Here we see it's an obtuse angle and this is also obtuse angle. This is acute angle and this is also acute angle. Okay. We see here for an example, this is a straight line. So this complete angle will be 90 degree, but it is less than 90 degree. So it is an acute angle. Similarly, here also we can see this angle must be 90 degree. This particular angle is 90 degree, but it is more than that. That means it is an obtuse angle. And the same is case over here. So if you are confused initially, you can draw the straight line. And if it is the angle formed is more than 90 degree, then it will be an obtuse angle. And if angle formed is less than 90 degree, then it will be an acute angle. Here, this is an acute angle, this is an acute angle, and this is an obtuse angles. Okay, or we can say both of these are obtuse angles. Now we see an interesting figure over here. It's a right angle, it's a right angle, this is a right angle, this is a right angle, this is an obtuse angle, this is an acute angle, this is an acute angle, and this portion we can call as a reflex angle since it is more than 180 but less than 360. Okay. Friends, we have discussed the basic terminologies in this session. In the next session, we'll be discussing more concepts of geometry. Do revise this session and let's see you in the next session. Bye-bye.